I'm also definitely going to miss next week. I'm making pancakes that evening.
Go on into your tube.
Oh yeah, it's starting.
As long as we don't speak about rugby.
Rugby, oh yeah. Are you bitter?
And you
Bitter.
Yeah.
from now on is live.
It's cruel.
So you should be able to.
It's fair in a way.
I think Ireland
Okay.
probably play better over the whole
I just need to go and bring some cable.
Okay.
Something. I'll be back with you.
Yeah, but I really thought France were going to win.
The guy was on the floor with cramps. Then he said, okay, he's the only one
Before I
who
leave,
kicked the
do you
ball
know
for the
it's gonna be just one speaker?
and then he regains his defense and then
I
kicked.
think there will be two.
Yeah, because
Do you-
you missed the
Are they
penalty.
here already?
There will be. They both of them have Mac.
Max. Okay. That's what I want to know.
Hello. Welcome.
Thanks.
Have a seat. Anyway,
I'll be back, Chef.
Yeah.
Some controversy about our use of
head injuries or knee injuries.
with VAR.
Yeah.
The youngster, he got his knee done. Younger, 19 years old.
Yes,
10.
he's out for months.
Yeah, but in the number 9, he's
I'm not sure who it is.
the rest of the.
Someone who hasn't turned up yet.
Ooh.
So some people are saying that they were not big enough.
Is this
The
the
new
first
one,
first run?
Yeah.
80 kilos, so maybe he was not strong enough to
Yeah.
resist.
Oh, yeah, that's my size.
Oh, yeah.
It's
Yes.
huge.
Probably
They're
Yeah.
very serious to a sort of
Yeah,
coordinator.
because they sent some bigger guys to after the number 9 and then
Just as one of the
like
regular speakers.
Yeah, to try and scare, to
Scare them,
intimidate
yeah.
him, yeah.
at the start.
Try and help.
After 20 minutes he was out.
Who did France play
I
this
might learn a
weekend?
bit.
Scotland.
Scotland has improved quite a lot in the last 3 years.
They were terrible.
Yeah, they were terrible.
Is it in
Let's
France?
not contribute too many poetic
I didn't
ideas.
check. So they are recalling some older guys. So the student 32 years old. I mean,
Maybe what's your background?
older. Yeah, who are playing for 6 years or something.
Is Pastore back?
On and off.
He was banned.
No, I think because he said something.
He's a scary guy.
Scary guy.
Yeah. Just-
He's huge. But
They
he's not
use
that
it for work or?
effective.
Yeah, for work.
A cold evening for a bike ride, huh?
He goes through the French,
I say I'm
something like that. I mean, he's been around.
Yeah.
Yes, I think it's true.
We have two laggies that are proven to be late classes, and he's just
Yeah,
but he's injured all the time.
he's a character as well.
Yeah.
He's got a theater.
Arrested.
Full potential of C++.
Yeah, he's a bit of an idiot, I think.
What
You're
you
more comfortable with.
where he was on feet.
Oh, I think maybe he
Or New Zealand, he was talking about
Too scary when first you
key to the
writing it. Probably too scary when it's first maintaining it.
That's a good question. I guess I've got about 25-30 minutes worth of stuff, depending on how long the exercises take.
Sure. Let me just
Justin's
go into
got another half
signal.
hour.
Thanks.
Yeah, you just start talking now.
1, 2, 3. 1, 2, 3.
I have sound.
Yeah. Okay. So. Okay.
Hello.
How are you?
Welcome everybody. Welcome on the PT C++ class. We have lots of new faces, which is really nice. I have no idea how many people is online. That turns to be standard, a norm. It's fairly difficult. I'm really sorry about the delayed link, because we still settling up things. We don't know exactly how this is going to be done, but for now, until Skills Matters managed to update their website, we will be doing this via YouTube. Once it's updated, we will move to Skills Matters website, and then obviously you will be able to watch there. It's a free class. We're trying to do what basically group ask us to do. So we're trying to follow the majority of the people. So if people decide that they want to do less advanced stuff, obviously we'll try to cater for that. If people want something more, then obviously we'll try to cater for that as well. But for that we need your feedback, yes? Today I see lots of people, so obviously we are going with the subject which we planned. How do we work? Yes, because so many people, I'll maybe repeat that. So basically, every Tuesday, we're meeting up here and we stream our classes online for those who, for whatever reason, cannot join us. So whether they are disabled or they are abroad or they got other commitments, whether it's a work or life. Yes, so you can join us always remotely. The people who want to start going and meeting with us on a weekly basis, you are very welcome, and you need the good IDE. As a default, we try to use IDE from JetBrains, called Sea Lion, which is a fantastic IDE. It helps us to, it's good because you can do a lot of things out of the box. Now, it's a commercial product, but because you are part of the group, we managed to secure a license from JetBrains. So I encourage those new starters to log on to jetbrains.com, download the free 30 days trial, and once we see that you're still coming, I'll ask you when your trial will be near the end. Email me your name and the request for the license, and we will. I will email you the free license that will extend the Sea Lion to use. And if you still continue after that license expires, you can basically extend it until as long as you're with us. So it's a good deal, so you don't have to buy an ID. After the meeting, after the meeting is completed, we always go to pub to thank our teachers for their time. They do this voluntarily, they're not paid. So we buy them a beer, yes, at least one. So you're very welcome to join us, have a chat about C++ and not C++ related stuff. We're going to beer shanker. After that, become a tradition, me plus Christian, Ollie, Justin, and a couple of extra people, we are meeting up for a lunch. Usually it's end of the week, Thursday, Friday. We're meeting up most of the time in Eats on the street. So we go there basically to eat and chat about what will happen for the next week for the class. Again, as I say, we're trying to cater for everybody, but that means sometimes we will have to do some sacrifices. So if somebody is too basic, he might not have an easy start. If somebody is too advanced, he might start actually it's too easy for him. But basically what we're trying to do, we're trying to adjust to the group as we go. If you go to our website, which is cpplondonuni.com, on the left side you will see one link which is called Start Here. Out there you will find all the basic information. You will find our Slack channel, where you're very welcome to join and participate. You have to send a link to request joining for Slack, which is free. Just send an email, just sign up, and you'll be emailed within a few minutes a link. We have obviously a YouTube channel where I try to keep all our classes recorded from the other sessions. It's only few because we started pretty much streaming very recently. Obviously we have our website. We have a subreddit. Yes, the subreddit is basically a place where we ask you to contribute. In a sense, if you think that there is something you'd like to do, yes, a project, a subject to be covered, put it there. And if other people will see, oh yes, I like that idea, they will upvote this. So the project which will get more votes, obviously will be prioritized, and we will try to cater for that. project will obviously have less, that will be dealt later. So go to that and obviously share your thoughts. Pretty much after every class, I ask people to provide me with a feedback. What do you think? Did we cover what you wanted? Was the quality of the class good? do you suggest any changes? Let me know. Without this, we are blind. So basically, I tell these guys, what should we learn? They tell me, no, Tom, you're an idiot. You don't know what you're talking about. We'll do something else. And then we'll learn what they want, not what you want. Yes, or what I want, depending on who was screaming louder. So that's pretty much from me all. We'll wait for a few moments for Oli, so please talk between yourself, introduce. Oh, by the way, it might be a good idea. We abandoned a little bit the subject, the thing for a few sessions. On your name tag, put a number. Yes, 0 or 1 is I never done any coding. 10, I am a developer, I work day in, day out. The reason being, this way we can try to swap you in between. So if we can see, let's say, on one side there is too many inexperienced people, on other one is only experienced people, so we can try to mix you and match. So it will be easier for you and more beneficial. So that's all from me. Thank you very much for listening to my chatting, and I'm passing to Oliver.
All right, hello folks. So today we're going to talk about move semantics. We're going to go a little bit more in depth than just move semantics, just to truly understand them. It's probably helpful to actually know a bit more about the type system itself. As usual, feel free to throw any questions up as I go along. Okay, so what are they? What are move semantics? As a simple example, we're just going to say we'll declare this empty struct T, we use class technically, but we're going to say struct. And we can use this in 3 different ways for modern C++. So one, just the type. So we've got struct T and it's the star object. Then we can do a pointer to it. So you can dereference it, access T. And then finally, you can have a reference to T. This is included because obviously you can't just declare T and my T. You can actually assign a real object to it. You have to do it on the line you declare it. I wish I could see my notes, but it's not showing up very well. Okay. So a key thing to note is that T star is actually its own type that you can take a reference to. So if I had a function that took a T star and, it's a reference to the pointer. So anything taking T star and, modify it, and whoever called it would see that change. So a pointer is not in the same class as a reference. Now, since C++11, we've got the lovely T and. And this is great because we can now actually distinguish. We can actually distinguish what kind of object we're dealing with. To actually explain that though, now we're going to get into a little bit of standards, which is L values, PR values, and a little bit more. So an L value is just something that lives past the line it's declared on. So, for example, simple enough, X is an L value. So we have this constant value 5, obviously, and it's the semantic L value is that it's going to live past the declaration, so you can keep on using it. Now, PR value, which is actually a new term they've come up with since C++11, is something that will not live beyond the end of its line. So, for example, if you declare, if you think of our struct from earlier, T, we construct it, but it doesn't have a name, so whatever that is just going to get constructed and destructed instantly on that line. So if the constructor printed hello and the destructor printed bye, you can see hello and bye just by virtue of that line running. Now we get into a special category which is called an X value. This is something we now have since C++11, I believe, unless Tristan wants to correct me.
Yes.
Yeah. And it can essentially behave like it's either an L value, so this thing here, or alternatively, it can actually behave on a PR value. So as a result, we have what are known as mixed types. And again, this is somewhat standard easy. You'll see where it's useful to understand in a bit. So we have something known as GL value, which is either an L value or an X value. And something that I think is hopefully already stands out is that really your sort of core base types are both your L value type and your PR value type. Once you start going beyond that, you're kind of having a hierarchy. So a GL value is either just going to be a standard X value, standard L value, sorry, or it's going to be an X value. Then the question is, what about R values? Well, an R value again, and this is something that was somewhat redefined in C++ 11, is now either a PR value, so this thing here, or it's an X value. But how is it useful? So, for example, if you declare a type T_AND, then it's only going to bind to, which means effectively work with, a GL value. So say, for example, I have a function. One of the parameters is this, T_AND. Well, I can't pass this inside it. So if you imagine you have the parentheses, you can't just write that line. Obviously, that's inside the function call. Whereas if you had X, which wasn't an int, but say a T, then that would work fine because it's an L value. Now, T_AND on the other hand would work. It's the opposite case. So now we can have a function that takes one parameter and it's T_AND. This guy will work. If you had Tx, you cannot pass x. There's a way to make it work, which is by converting it to this x value, but we'll demonstrate that in a bit. So let's actually apply this. Consider the following code. We've got, fairly simply, we've got a struct, which we call t, and we've got a constructor for t, which takes a const reference to itself, its own type, and we've just defaulted it as a special. We've also got what we call the move constructor, so we take T_AND. We're going to number these 1 and 2. They don't actually do anything, and we've got an instance of the object here, which we just call obj. All right, so here's where the work comes in. We're going to invent some ways to actually use these. So just before I do, we've got a function here a, and it takes t. It takes t. We've got a function called b, which just takes an L value reference to t. And then we've got an overload of b, which takes an R value reference to t. Okay, so we've got 1, 2, 3, 4, 5. Lovely. So, first one. We've got our object, of t, an instance of t, and we're calling b with that L value. So, can anyone have a guess which of these three it's going to call? And it's probably obvious it's not going to be that one. Anyone know?
Second.
First and second.
Which one do you mean? Which number?
4.
4. Absolutely correct. Yeah, that would be number 4. Because obviously this is an L value of type t. The overload of b that wants to take an L value, we've numbered 4. So that's absolutely it. All right, next one. Now we're invoking std_move. So std_move is just a function in the standard library that effectively static casts your object. So is anyone not familiar with static cast? Hands up. Okay. So within C++, there's a built-in function which will let you say, okay, I have, say, object which is type t, and static cast lets you say, well, I want to consider it to be a different kind of object. So static cast applies some rules. So I can't just go, I want to static cast this thing to an int, because t is clearly not an int. It also doesn't implement a conversion operator, so this struct doesn't say I can be converted to an int. So consequently, static cast would say, oh no, we can't compile this. You're not allowed to do that. One thing you are allowed to do though is actually redefine what kind of reference type it might be. So when we call std_move internally, it's just doing a static cast to a t_AND. So it deduces the object as a t, or in this case, it's actually a t_AND, strictly speaking. And it says, yeah, we'll just make this a t_AND. So with that in mind, anyone guess which b it's going to call?
Number 5.
Yeah, number 5. Because this move converts it to that x value that we just mentioned.
What if you didn't have that second constructor? So what would the compiler tell you?
So
you can't cast it?
No, they wouldn't have any bearing on it at all. So even if we deleted this, because in C++ 11 you can mark it delete, we're not actually invoking the move constructor here. So this will work just fine, because no matter what you do inside its constructors or whatever, you can't prevent this function from taking the R value reference to it. So as another example, I did it. Here we have just a t that we're constructing within it. This object does not live beyond the line. So which one do you think it's going to call now? 5 again? Yeah, absolutely right. So this is the x value cast. We say I'm telling the compiler consider it to be this. In this case, it just is. It's a PR value. It's not actually, because again, an x value is a conversion. It can be an L value, it can be an R value. So in this case, it just is a PR value, so it goes straight here, no problems. And it's just a default constructor.
Sorry, if you didn't have number 5, that function, if it didn't exist, what would B standard move object and BT do? Would they call number 4?
So if we got rid of this overload, got rid of 5, this one I believe should still work. Is that right, Tristan? Std move should still work, right? It's next value.
What will happen in that case? The temporary cannot belong to the non-const L value. So 4 is out. 4 is out of the question. So I think it would call number 3.
Well,
no, it can't call 3. No, this
is
is
an A, not a B. Sorry.
Think it would be a compiler.
Yeah.
So this is a PR value. This is guaranteed to fail. So if we deleted 5, this would not compile, I'm sure. This one though is an X value.
No, that won't call. If that was const and, it would be alright.
Okay, great. So in the case of deleting that, this is definitely out. We're pretty sure this is out. Okay, and then finally another one. So this is a bit of a different question for you though. So we know we're calling A with this object, but A takes the actual value type. So is there anything anyone wants to say they notice about this, what they think it's going to do? We know it's going to call A, but because it takes a T, does anyone know exactly what that changes, or how that changes things?
Copy by value.
Copy by value.
So yeah, it's taking the value. So in that case, it's going to invoke a constructor. So it's going to take this object. This object will basically be the parameter to one of these two. 1 or 2? 1, exactly. And then of course, the only option left, I think is fairly obvious. If we move object, it's going to invoke this move constructor. Does that seem fairly clear so far? I'm not hearing any objections, so I'll go on. All right, so let's look at some actual practical applications of where this is useful. So it's great that we can do this, right? It's really fantastic if you actually know why. Firstly, we know if we're getting a temporary or not. There's something I wanted to go into here, but I thought I'd say for another time, which was ref qualified member functions. But yeah, basically you know if the object is actually alive past the line it's declared on, or it just dies instantly. So that gives you that's some useful information you can actually have. Although alternatively, someone can obviously use say std move and just say, well, I'm gonna say it's one of these, and you're allowed to pretend it's not going to live past the line. That has some contractual concerns within your code, which we're going to discuss shortly. God, I wish I could read my notes. Yeah, here we go. Okay, I'm almost on the button. So a good example of this is we want to take t and as a parameter. So we're saying we'll steal stuff. We're going to take stuff out of this object and leave it in some unspecified state. So after you've given it to us, the object is still there, but it's probably not safe to actually use it anymore. About the only thing you can guarantee will work is the destructor. Yeah, as I said, you don't know what the state is. And yeah, so the destructor is pretty much the only thing that's guaranteed to work. Obviously, if you wrote your own class and your class had Tian, you can make that mean whatever you want it to mean. You can say, oh yeah, it can move from it, but we'll reinitialize the object as well, so it's still safe to use. You can do that in your code, no one's stopping you. It's not a semantic of the standard library, although it does vary somewhat by classes. Yeah, I'm just getting way ahead of myself now. So, as an example, in the standard template library, there's a few objects you can sort of carefully reuse. Stood vector is an example of this. If you move from a stood vector, you can, I think you're allowed to safely move something else into it, for sure. And I believe you can also reserve safely to get fresh space.
Well, from a moved from vector?
Yeah.
Yeah, you can ask its size. You can erase everything that's there.
Yeah.
The documentation for vector tells you what you can do.
Yeah, right. If you look at CPP reference, then these things will tell you. But the general rule is if you move from an object, read the reference to make sure that what you're going to do with it afterwards is safe to do. All right, time for an exercise. I want you to implement your own. Whoa, what's happened here? This was not. There's supposed to be.
I think that.
No, it skipped a slide. Did we skip a slide?
For those people who don't have laptops, you're very welcome to pair up with other people who do. I got laptop, and anyway, feel free to join the people who have the laptops.
Okay, so we covered that. There we go, that's the one.
Not interested in the exercise, it means we're available to help.
There you go. So that's the actual first exercise. Somehow skipped a slide. Anyone needs help, feel free to ask.
It's the password to the
I'm going to check
word.
it out, and if you guys haven't got laptops, then we can work on it. So just give me a second to check it out. I haven't seen this exercise, so I don't know. Edit. Each Okay, so here we've got instructors.
Yes, we love code.
Is it instructor that takes T by reference?
Okay, yeah, sure.
I don't know how familiar you are with C++, so this might seem like magic. Okay, implemented a structure taking a const reference to its own type, it should be set to 3. Okay. What do I have to do? Tell me what to do. Well, if you want to take his receipt, writer. There we are. Text. C line. I don't know how to actually make the text bigger. Never mind. Okay. Does anyone want to type?
Should we figure out who we are first?
So it's this one.
Yeah. Okay, well, go ahead. Okay, so that's we haven't done the last. We haven't done this one. So I think what we've done is we've passed this test. So maybe have this one. Okay. So make operator equals. Also taking. That should be a const reference, right? Because we've already done the one with the non-const reference. Operator equals 4.
Yeah, I threw those in just for the sake of it.
Yeah.
To help them explain which one is it.
Operator equals also taking a reference.
So it's the non-const.
Non-const. We've done it wrong. So done non-const. Should this one be?
Oh, sorry.
Let's go for this one.
Checking the solution. The solution branch.
So how do we get this? Do you want to have a
Yeah, one thing to note, sorry, there's a mistake in one of them. The first one to take a reference is non-const, then the second is the first one's const, the second is non-const. But you can do it in either order.
Oh, okay.
That's command.
This one. Command V.
Yeah. I like this simple lazy approach. Just copy paste. So that's normal, nearly right. We just need to change that to 4. So now, try running it. You'll probably still get an error for some minutes, but no more test 6. I forgot to test 6. But it's no longer complaining about that side. We passed that. Okay, implemented a constructor taking R value reference to its own type. V should be set to 5. Yeah. Yeah, my cables. One is last place. Yeah, usually I'm taking the turn this week.
Oh, yeah, absolutely. I just installed the CLI and I'm looking for the target class, which should be the main. Essentially, I can't find it.
What are you trying to do?
I just downloaded the project from GitHub. Essentially, when you set this thing up, it's looking for a target class. I don't know. It's got to be main, right?
Alright, no, it's build target.
All right.
Have built, have already
There's a
the
CMake
compiler.
Yes, yes. I mean,
target.
sorry,
Small
small
target.
circuits. Yeah, I did that.
And then you get it executable, does that count?
No, it's not. I mean, it's
No, it hasn't
I
detected.
think that's because, oh, you know why? It's because your root is one level up. If you make it see this as the root, it should figure out the CMake lists for you.
Okay.
So value that's master.
If I'm here,
Yeah. So make your project root.
And we've all had
have this column as your root.
oh, this one has my
Yeah.
root.
Yeah.
Okay, so set as.
Is there a way to do that? Just reopen project file.
I reopened it from the location exit. Let's try again.
Okay. So, you're doing a static function.
This is where the project is.
Yeah.
Okay.
I'll cancel that.
Let's try it out.
Okay, so you just go to the file menu,
Wow.
open, and then just point it, go one level down,
At the end of this
scroll down,
At the end
one
of
level
this
deeper,
comment here.
and then, yeah, that one, value
This
category,
one.
value category.
Oh, okay, cool.
Okay.
Let's see.
Hopefully, it'll figure it out.
Oh, it has to return T. Okay. So,
Okay, it looks like.
okay.
Right, can't find it. Oh, maybe it's just indexing it now. That'll be yeah.
You don't have to create the
Hmm.
Yeah.
It's a Core i3.
And takes in.
Alright, fingers crossed.
Yeah. Thank you.
No worries.
So these errors are actually from the code that's referenced.
Oh, yeah.
The errors are from the other development file. This one.
implement an operator equals.
So we never really know operator equals.
Yeah, that's why I'm saying it's a mistake. So that one's meant to be const.
No, I'm not really here.
It doesn't matter. One of them needs to be const, one of them needs to be non-const. I believe that's the const one. No, it takes a const.
Yeah.
Let me correct it, then you understand.
Okay.
Just put it anywhere else. No, the comment is correct.
I'm just going to check these guys to see how they get.
And it takes into T and
Alright, I'm going to give it another 3-4 minutes.
Making
Crack
sense?
on. Oh, okay.
yeah, max.
Jumped in when we were doing it quite advanced things. Oh, so you yourself a complete newcomer to C++? Yeah. Well, that's what it is. Bash scripting. Oh, yeah. Okay. So, yeah, we said we're in week 19.
So just clicked on it.
Yeah, jumped into some quite advanced stuff. Yeah. Which is we got a load of newcomers this week. I don't. So we must have been advertising somewhere. Doing pretty well. Yeah, we've jumped into some quite.
You did say that this one should be a
references. So declare a reference for this little okay.
Oh, is this the last one? That's what you meant.
Which constructs all the tasks. So if you don't need Java or anything like that, no, I think.
Yeah. So the test 6 is.
Oh, you're missing one. So there's one more to do. Static function.
Oh, okay, cool. Okay.
And what this does is this constructs this type T. And this is a constructor that takes the T reference into the constructor on itself. Yeah. Right. So in this case, actually, the constructor, this argument doesn't have a name.
Oh, all right. I've already got one.
But C++
Like, in fact, you would be affected by you.
Yeah, okay, so
every
Are you alright?
so that's a bit different. Python variables have types, but in C++ you have to do these. So save each type. Integer or float or string, exactly that. Right. Yeah. So the word struct is used to introduce a new type. So here we're creating a new type.
But yeah, if we do work right, I will return it.
So we're creating this new type called T. What we're saying is every time we make a T, we construct a T, it's going to call one of these constructor functions. Months ago, I spent 2 hours so I really on the drift. Yeah, I really am racing through. So we're declaring to breathe to see.
Stack gets a start.
The constructor is just a function.
It's just a function you can access without having to instantiate constructs.
This is a function called capital T. It takes arguments.
You can't touch me.
One argument.
You're not allowed to. You need to return something. It's not a member function, it's a static function. It doesn't have an instance.
Yes.
It's a little bit of trickery involved figuring out what you do. So you need to return 5. What will you return 5?
So every time you try to construct it, you
this
I should return from this.
what is that? That's the move constructor. Yes. That's the move constructor. You return T. So you need to
So like I know. What's this?
It's a little bit of trickery. Tables.
yeah, neither do I.
You need to you need to return
So you
T
need to have
table.
in
So when we construct a text, in which case we
So
then
what we're doing is we're
actually
creating two copies.
these
Creating
objects.
a copy
to
from
Has the same contents.
When we use this constructor,
temporary from the same line.
which would be
construct a temporary, construct a text, and then return a
So
text.
this is
Construct
interesting.
a text,
Existing.
construct a text.
It calls another constructor. It calls a function.
Because I don't
This is recognized.
This is very similar.
that works.
This is
I think you need to construct the inner object, so you need to you need to make the inner object. No, return's fine. Return's fine. Get rid of the get rid of the and then you just inside the T that's inside. That's just a type. You need to actually make it the TR value.
Oh,
You can do it all in one line. You don't have to carry it. So you're constructing the outer T, right? And simply you construct the outer T. Parentheses, right?
If anything, this is probably
Okay.
better used in other words.
I think it would have worked if we did.
Use those tables. It's up to you. No.
Information's inside the
The
diagram.
extra set of
So you want a T constructed from a constructor. You want to construct a T. Make a T. Construct a T. Construct a T.
So you want to it does work.
Go back to where you were.
This is why I did the other way the first time.
Back when you had just that. That's the
okay.
So that's the start. But you want to actually inside the T thing inside. You want to make that one B constructed. Just T just means type.
Yeah.
So
I think
you've already done the outer one.
Because outside of the sub,
That's the constructor. That's the constructor.
Sorry,
It's fine. I really am racing through this. It's
So it means
static
Almost. What do you mean almost?
That one.
to call it.
Which one did you want?
I'm just trying to explain
The other one you need to
all
say
of this is doing. So what we can do is now we've got two different
point to
variables.
my object arrow method.
We can set
This one you just class name to columns.
because you see that. So this
That means
this time we're not running
inside
constructor.
the static
We're-
method. You don't do this. If you try and use this, the compiler will say error.
So we're setting, we're not creating any new variables this time, but we're saying we want the value of R2. So if you think about static for this we create
I've managed to lose the remote somewhere. On my one.
So yeah, so that's
next to you.
oh, sorry. This is
Oh,
going to
one
create new values.
So what you need to return is a T. It's not the same object, it's one that's passed in.
Even though it's a name variable. So we can
Oh, yeah, sorry.
Can we read that?
So T, imagine the return is actually
to create a new name it.
So
The reason
we
I
need to do
think this one is
return.
better.
Oh,
This
that's
is saying okay, create another new variable.
Imagine it's R2
It says it equal to.
and then later you
Nothing in this case, no.
Again, we could do
they
this.
don't know that you.
What's that?
Okay, so
I was simply saying,
we're wondering. We're wondering.
take the one
What
with
is
the
more
copy it.
But for myself, I prefer that one.
This time,
to that one.
we're not
Because
creating
when
new
we're calling
variables,
test
we're
6,
looking-
customer, you won't necessarily know that you're moving.
What we want to do is we want to send this instead of being equal to the next one.
You are correct.
So the heads up for that one.
So this one's a declaration. This one's an assign structure. So we're assigning new value.
Okay, fine.
Oh, okay, so overwriting what it was.
Yeah.
Yeah.
Sorry.
Classic way to
So I'm running through, and whereas previously I spent 2 hours talking about structures, I'm trying to do it in 2
So taking a challenge, okay?
just a space.
So I'm just trying to explain.
And then
Because
we don't care about the value of
semicolon.
Yeah.
So int is a built-in.
You've got to return something, so just on the next line, return.
So all these things automatically. But
can define our own type.
So
In this case, we're defining our
if
own
you open
type.
command, you're on Ubuntu, right?
And when we define our own type, we
you've
can
got
tell it,
sequence
we can tell the compiler how
when
to construct things or when we
And it's returning it.
So tell it
Two things we're missing. One is we got the the same as the one that passed in containing the same data.
If you return them, if you create them,
You do it.
but we can have
Yeah, one should be the same value.
That doesn't work, yeah, so that
trying to raise the I do have so if you look on our GitHub,
this one should
you guys
should move to
is it from the same so this application so it's just get on so if you go to github.com
On the declaration.
/.
Are you doing it differently? Go into
How are you getting on?
Actually, the old stuff is which is just raw pointers and so these kind of, you know, seemed like a big move and stuff like that. Because since 15 years ago, I started
you made your
using these stuff
If you start, yeah.
So the thing is that I just have to replace it.
oh yeah.
Because the main thing is that someone tells you they never teach you anything. They teach you how to learn. And that's the main thing.
We try to publish our website what we will cover for the next class. Because we try to release from week to week.
Yes. Ollie, Justin, and Robin, they are like experienced developers.
Sure.
Yeah? So raise a hand if you're stuck, then they will give you a help.
I will talk to them. Yeah, sure.
I'll try to help as well as I can, but you know, I'm still learning, so I'm far from being
Sure.
good.
Oh, you see what?
Yeah, and I have GitHub open.
Oh,
well.
System.
Right? Okay. If I manage to fix this compiling error because it's a static function, I have developed.
Oh, you cheated.
What is that?
So if you correctly implement everything in NAD, it won't be compiled everything. So it doesn't compile until you correctly actually
Oh,
implement
okay.
it.
Because it turned from red to white, so I thought it was
No,
it was done.
No.
I know, because there are errors here. What I was trying to tell you is that since after C++ 98, I haven't done it. So that I used to be C++ developer for MFC.
That's a good. Do you want to sit here?
15, 18 years ago. And then after that, I became a Java developer. Now I'm trying to wrap, but these things, stuff for printing you, they are not like, you know, your raw pointers and classes and print functions and stuff like that. So they're pretty new. I have to go home and look at the syntax.
Okay. Yeah, I validate all my solution.
The issue is that at least I know what you're going to talk about, then I go home and investigate.
Steve, I will distribute. We'll chat later.
Alright. So this comes back to life. Okay, I think we're going to press on. That's okay. I've got one more exciting task for you to do as well anyway. So, right. if I can get back to my speaker's notes, if this is going to behave itself, it is. So I guess we'll recap because we somehow managed to skip and see this already. But obviously, as you can see, it's quite useful to be able to distinguish between the two of them because you know obviously whether you have a temporary or you don't. And as you've used in the examples from just now, stood move obviously enables you to say, oh no, I can use this like it's temporary. And we can form this lovely contract. And yeah, if you are designing your own class, you can make this mean whatever you realistically want it to mean. You know, I think that probably a good example of this is that stood array in C++. If you use some sort of standard value type, like say you have a stood array of integers, the move constructor is equally as expensive as the copy constructor. A move constructing stood array doesn't really move because it's just on the stack. Now, if you had something like a stood vector, which allocates the memory and has a pointer to it, that's really cheap because now you just go, yeah, I'll steal your pointer. You don't have this vector of ints anymore. They're mine. Cheap. So depending on the actual kind of container you use, you invoking the move constructor isn't necessarily any cheaper or doesn't necessarily even gain you anything. So as I said, yeah, for types that do actually use it, obviously you need to be careful about what you do with the object that's left behind once it gets all its stuff stolen from it. If it's the STL, then just read CPP reference. Like if you want to call, say, you know, the array index operator or the resize function, it will tell you right there in the reference, oh, if you move from me, you can't do this, or oh, you can do this. All right, so now on to yet another exercise. Oh, you implement SharePoint, go. What I do want you to do is implement unique pointer. Not a full-blown one, but a reasonably simple one. And we're actually going to be using templates. But if you miss that, don't worry too much. That's kind of filled out for you. I can be interested in, and Justin can help anyway. So there's your link. Hopefully this one should be a little bit more useful and intriguing. And I did a bonus task just for you, Tristan. Well, I think you'll find it pretty easy.
Well, these guys are using my laptop, so
okay. Also, the bonus task is not actually tested, because otherwise it wouldn't compile. So if you do it, then just let me know and I'll validate it for you. Or you can look at the solution I did on the solution branch.
So, does everyone know what a unique pointer is?
Yeah, did anyone not see the unique pointer?
Sorry?
I guess there's actually quite a few people who didn't.
Yeah.
I'll go.
So what it does is
I'll go for a unique pointer if you want. I'll just go for it now.
Yeah.
So the concept of unique pointer is everyone relatively familiar with the concept of just a regular pointer? Is that fairly familiar?
Yeah.
So, well, just in case, I'll say anyway, it's fairly quick.
Anybody's not feeling comfortable with that?
I'll just start from the beginning.
Let's leave the hand.
Yeah, please raise your hands if you want the from scratch.
Okay, so
okay, that's 2 votes, good enough. So a standard raw pointer, so you know T star, it means that you don't just, it's not the object, it's pointing to the object, but not necessarily. So I can have a pointer that points to null, doesn't actually point to anything. If I try to use it, I'll just crash my program. So generally in old C++, you'd have like T star, so some class type equals new T, and then that new operator will go to the operating system, say, hey, can you give me some memory of this size, which whatever the size of T is, the compiler knows, and then the OS says, yep, here you go, here's that memory, and then what it will do is it will run that class's constructor, fill in that memory with whatever it stores, and there you go, you've got a dynamically heap allocated object. So the thing is that you have to then get rid of that object. So I don't know, say someone's going to send me a file of 5 megabytes. So I obviously don't know when I build the program how big a file is going to be when someone sends it to me. So I will have to make my code go to the OS at runtime when it runs and say, give me any amount of memory, and the OS goes, fine, here you go. But then when I'm done with it, I've got to just throw it away. So in the olden days, what you do, if you were using C or like old style C, C++, you do new, you have an array of bytes, you figure out how much you're going to get sent, so give me 5 megabytes, new T, and that T is, here's 5 megs. Then you do your processing, then you delete it, so you just call, so you type new, delete. But what if you forget to call delete? You just delete that memory's leaked now. So you receive a file, get 5 megs from the operating system, and then you just forget about it, never give it back. And then what if your program's job is to process lots of files? So you keep on asking the OS for more and more memory, and you never actually give it back to the OS. Eventually the OS goes, I've run out of memory. That's it, it'll kill your program will get killed if it's Linux or whatever, or you'll potentially crash the whole machine in the worst case. Unlikely these days. So obviously the best way to do that is, what if we use the power of classes to actually not have to remember to do it? So obviously in a class you have a constructor and a destructor. When you construct the object, constructor runs. When you destruct the object, i.e. when the object goes out of scope, so when you return from your function, for example, then the destructor is automatically called. So I make a class, instantiate my class, do some stuff, return from my function, and because it's now out of the function where it was declared, the destructor runs and does whatever it needs to do, which is a really nice idea for pointers. So the concept of unique pointer is it takes a raw pointer, which you can allocate with new, and you construct it with that object. And when it goes out of scope, so when you allow the object to die, its destructor frees the object for you, so you don't have to remember to do it anymore, so you don't leak memory.
How different is it from the smart pointer?
It is a smart pointer. Are you thinking of auto pointer?
Original.
Yeah.
Smart pointer.
Auto pointer was a decent attempt at the time. Obviously, the problem with it was we didn't have move semantics back then. So the benefit of having move semantics is that once I construct this object, someone else can take that unique pointer. They can physically say, I want a unique pointer, but there's no way for me to accidentally copy it. So it's not possible to have I can't just accidentally copy the class.
Okay.
Which you could with auto pointer, right? You might not declare and you might forget to take a reference and oh shit, I've now got 2 auto pointers holding the same raw object. It's going to be a double free. But with move semantics, you can't do that. If I want to take, you have to physically call std move, and when you invoke that, it's going to say, yeah, that's my pointer now, and the other guy's, the old instance has an old pointer. So that's the safety it gives. Shared pointer is another one which Tristan, you did a talk on these, didn't you, a few weeks ago?
Yes.
Yeah. So shared pointer also has move semantics, but it's actually copyable. So internally, it actually does a reference count.
I mean, the name says that.
Much more
One
complex.
is unique, the other one is shared.
Yeah. But yeah, for this task, we're just going to focus on doing our own version of unique pointer. So the idea is that it's unique because only one person can hold the object at a time. That's it.
Wouldn't template not break the whole thing if you would change the C++ to 17 so you can deduct the template from the constructor?
Give us a list of instructions.
So if I use 17, I wouldn't have to declare template type when I use it.
Therefore your tests will pass, wouldn't it?
No. Oh wait, hold on, show me.
So that's one way of doing it.
No, they still.
He says there are 2 ways.
Because they're testing implementation, not just the type construction. The type construction will work anyway. That's pre-declared.
Yeah. So that's
from an
that's one way. The other way, another way.
idea or design point of view, essentially we have to create a class that
This is called
is
member
sort of a
initializer.
template which can take any type, right? It has a destructor and has got a member. This member is actually the one that is your pointer. And when it goes out on the destructor, you can
don't
free your
explicitly mention it
free your object that you allocated, right, during construction.
So if in the case of unique pointer, it has got a release member function.
So that means if one owns the pointer, an address, and if you move it, right, you're not the owner, or at least the object that the pointer was moved from. It's like the detach.
Well, it's a unique pointer class that was moved from.
Yeah, okay. It's just like a detached or ATL detached from. You just pass it, and you don't own it anymore. But isn't it dangerous if you mistakenly try to call anything with that, then you don't get some sort of an exception or segmentation fault or anything like that?
So if you stood move from a unique pointer,
okay, so
if you stood move from it and then try to use the object afterwards, it'll crash. But I think in terms of within your code, you've obviously got that lovely state as memory leaks.
Maybe a method that would say, okay, there's some sort of method that would say, okay, before doing the unique pointer, if you call get on that and it returns false, then you know, okay, this pointer is.
So there is actually an operator call on to unique pointer, and part of the challenge is to influence the operator call.
Oh, I see. It reminds me a lot about.
So there's a conversion operator that will be true or false depending on whether it owns the truth or not. But technically speaking, you could write your own version.
Yeah, a similar thing exists in Java, but it gives that to you for free. Java.
Java.
Yeah.
No.
So now that's the default constructor.
And also the thing Java, that's the you don't have destructors the closest you can come, it's fine.
Yeah, but I was talking about something similar. It's when you want to null check anything. No, when you want to null check anything in Java, right? Initially, I mean before Java, you had to go and say, okay, this reference it's not null. Yeah. But this thing, if you just say get on it, there's certain class which you embed your referencing. So you call get on it, if it returns false, that means it's not something that's.
So now what we're saying is when we run this constructor, which is
I think most IDEs nowadays, if you have any code that's going to NPE, you can usually detect it. You can see the whole usage tree. So it's not
no, we're assuming that
I have to adjust my mind. I've been a C developer.
I think the nicest thing they've added to Java really is try resources. You know, try resources.
Yeah. It just releases the file handler for you. You don't need to clean it out.
So you just inherit from an interface, or you just implement an interface rather, and then add a close.
It's just a memory address.
It's still not like C++.
This constructor takes the memory address by that. There's no ampersand.
But this thing is gibberish to me now, because I remember everything was very close to C, but you had your classes and the old pre C++ 98.
So it has no
was a time when we had raw pointers and stuff like that.
In terms of class structure, in terms of language syntax, it's not that far from Java.
No.
It's very similar. Yeah, I mean, probably the weirdest thing I guess now is like Java 8.
The concepts, right? The concepts and the names are strange when I hear them for the first time. I guess if I go home and scratch my head and read around.
Yeah, I think the best website for you can CPP-reference.com.
Yeah.
Everything.
Everything like that.
Yeah. In terms of language, yeah.
I was listening to Herb Sutter earlier this year. Yeah, he was talking about auto reference, something like that. He was insisting that. Yeah, but he was saying that this is really good. And I didn't understand it because this thing was a new thing to me, but I kind of managed to hear that.
How's everyone getting on, by the way? Anyone need any help or cracking away? Just fine. Positive.
So I said this, we can say equals default in order to say to the compiler, please can you generate this for us?
I know, I see.
There's also another thing you can do, which is to say equals delete. And when you say some function equals delete, it's saying you cannot call this function. If you try and call this function, it's an error. Actually give you an error message that says attempt to call a deleted function. You can't do it. So in this case, we don't want to be able to copy a unique pointer because that's the whole point of being unique. We copied it, and we have two things that think they own the same pointer and both try and call delete on it. So by banning, by stopping it copying, it means we can't get in that situation. We only have one owner. So we want to delete our copy constructor. We also want to
again on top.
To figure this one out.
That's what when he said our main internal time useful. That's what
our internal pointer.
So that's an instruction. That's just an instruction. So first of all, you should probably give the parameter a name.
You okay? Yeah. Better. Yes.
Yeah. And then if you look at the bottom of the pass, you'll see that there's already a very little flare.
We deleted the copy constructor and copy assignments. Now we've got to write a new constructor.
Yeah, you need to expand the T.
Somebody wants to take that. Well, you can tell me what to write and I'll write it. Okay, so first of all, we need a name for this argument. RHS is a good one. Just consistency up there. So this is saying when we construct a new unique pointer and we give it our value, what are we going to do?
T is still you're assigning a point to a type. So you're assigning a pointer to compile type and it's not.
We need to in our
It means if someone, it means if someone calls, it should fail to compile. It should refuse to compile. The compiler should actually say attempt to illegally call this because it's deleted. I'll give you a fair bit of clue there.
Actually, that's how I imagine I would delete. This is my first info. Is it good?
Yeah. Okay. My code obviously tests for that using type trace. Because obviously I can't try and call it because it won't build. So I use type trace. There's is copy constructible and is copy assignment. So my test is finds that that's false.
So what it's saying is this is the move constructor. So it's giving us something that is about to die. Right? And what we're saying is, okay, before it dies, we're going to steal the contents. The first one. And then when it dies, it's not going to take anything with it. It's not going to delete the internal. Right? Because we've stolen this one's supposed to be. But we have to make sure that we set other.ptr. Otherwise, when other dies, function destruction delete the thing stolen, delete it.
In a code, how to represent that? So it has to be dynamic cast rather than static cast. No.
So you shouldn't need to use any casts.
How I write move assignment.
So the compiler thinks, hey, I want to use
assignment operators should always return value. Should always return.
how would you do that?
Do you know that C++11 feature? So Tristan talked about how you can default constructors, right?
We need to do.
Do you know how to default?
Default constructor equal default.
Let's give it a name first.
So there's also a feature they have in C++11 to delete, and it's pretty much the same.
So what do we need to do
Until the
function?
They just put delete in front of it instead of default. Am I correct?
Yeah.
You use the keyword delete.
Yeah. It's just it's a compile time safety feature. So the idea is that if someone tries to call that function, you refuse to compile.
You enforce your
this one.
Here, yeah, you're saying you want that. But another example of where this could be good is, say you had a method, an instance function
that has to be initialized.
Well, so what I was going to say was, imagine you had a function that takes a pointer, so it takes t star,
Yeah.
right? But then you want to say, well, I don't want to let you pass me null pointer, right? So you could have an overload that takes null pointer t and delete it. So if they ever think, oh, I'll just pass null pointer,
Oh, okay.
you can't do that.
Okay.
That's another good example.
All right.
So this
Yeah.
is
So it's just a safety thing.
Yeah.
We might be already holding a value.
Instead of actually
So what's going to happen to
the
the
actual
thing we
object,
already
gives a
already
reference to the object.
Yeah.
This trying to copy.
Okay, so that's okay then.
And you
But
not try to copy the wait, no, it's
so we return the reference here, yes, to the we overloading operator call.
Basically, these two you've got the first one done.
so basically that would be invoked if you have other errors, for example, unique pointer, name.
Is this struct still the same as old struct? Everything is public when you have structs?
Yeah, default
Unless,
visibility.
yeah, unless you say right.
Do you want to copy the object?
Yeah, class of.
You don't want
Yeah,
the object
but
to copy.
So basically,
But they're otherwise
it's the other way
interchangeable.
around.
Then it will get default.
And you
or
don't know why.
you mean like this?
So yeah, so
I mean,
one thing
they're
we should do
interchangeable.
Yeah.
It's the inheritance visibility and
is
the
to delete our pointer.
Okay, that's the only difference. But a struct could have features. Yeah.
That's the one. Free cup of coffee for you.
Oh, okay.
Is that just C?
What we want to do
Reference.
Yeah.
is our pointer.
Included utility. You have to do that.
Exactly.
It's
Well, we did something that's
one for max.
You know.
Oh, you do.
This is what you have more than plenty of work.
Yes, it does. Yeah. Because if these two are the same value,
There is a page.
steal the object, basically.
That is the macro.
yeah. So if we had what we had before, where we were first calling
Yes,
deletes,
this
and then swapping voters, and then
What's the difference
that could
between
get
capital
rid
letter
of
of null and null?
So null is a horrible macro from C, and it obviously is just hash defined null 0 usually. Null pointer is its own distinct type.
Oh, is it?
Yeah, but also it can be used. But basically, if you're writing C++, modern C++, never use null, never use the macro, use null pointer.
Oh, okay.
Yeah.
That's the new trend.
Stop only set the original one to the null pointer.
The problem is
I would
that this was copied from.
Yeah,
Yes, the
and
max.
then I can only do
You can even
one.
go the whole
It's
stack
very
of
useful if you imagine
transfers, but
you have a function for free overloads now.
Yeah.
With modern C++, I can have one take I could have one of them take null pointer, specifically handle the case of getting a null pointer, and then it can have an overload that takes
this
it
function will never throw.
if there isn't null point, there's a null state, so it's just 0.
Yeah.
Between those three overloads,
Yeah.
an actual pointer, null pointer.
So the purpose of no access
Okay.
Yeah,
is so the compiler can generate better code for those.
So the compiler knows
You want
exactly
like
which one to take. In that case, the compiler can get
So using null pointer.
Then yes, so in C++ 11 that means the same as no
So
access.
it's right now.
Middle dates.
Pointer
But
you
that's
have
actually
no,
deprecated. That's the
nothing that
So
returns
they want to say no
these
access.
testers T star.
So I think in C++
Pointer to T
17
star.
you're not allowed to say throw.
Point PTR is T star and pointer is unique pointer. So you need to access pointer inside.
Yeah, exactly.
So no throw is two things. The first thing is you are indicating
Would
as
it
developer
be
anybody
really
calling your
like that?
function. I'm not going to throw an exception.
Actually, just access
And that's going to be how you should
pointer.ptr
use it.
because
However, it does have a
your
more
class
important meaning to the compiler, which is that if you do somehow
that is
manage to
already
throw an
important.
exception,
So
if
basically,
your
you
no
get an
exception
object
function
unique
ends up
pointer.
causing an exception to throw inside its scope, and it's not taught
even access to the
whole
private
program
fields of the
terminates.
class.
So
So
when you
you
say no
can, for
exception,
example,
generally speaking, you should make damn sure that there cannot be any exceptions. If there is one, goodbye, no one can catch it.
So if you set pointer.ptr to You still need to.
When you do a new unit constructor and we do a C++, what's the difference between curly brackets and parentheses?
Oh, so that was a new feature.
Because I just saw
Yeah.
calling constructor.
Yeah.
I changed it to parentheses just but it didn't net.
It's just a new piece of syntax added in C++11, and the reason for doing it is because of the most vexing pass. Have you heard of that? Most vexing pass?
Most vexing pass?
Yes, pass, you know, as in passing a file.
Oh, parsing.
Yeah, yeah. So that was basically what it was created. Like the simplest example is where, say you get something called header, right?
Okay.
So you'll do like int, not int, sorry, that way, obj x, and then parentheses, right? And then what you wanted to do was actually instantiate an instance of obj, right? But actually you've got to include the header. But because it's parentheses, the compiler's just going to go, oh, you can add a function, okay.
You guys, it's
And that's very good. Whereas the syntax, there's even crazier
Okay, it
examples.
just tells you, okay, it's not a function, it's a constructor.
Right. It's to prevent the most vexing pass.
Also,
We use
the
them
destructor, so as soon as we reach this curly brace,
for everything that allows it, then you'll say it's just more readable code. It's just more
Certainly
readable.
more elegant.
So the instance that is point of before
perfectly fine.
can all access to each but like you got like the ownership of this code. So it's now in your responsibility on this instance responsibility. So that's basically stealing the object.
Destroy the existing object any, and then assign
The pointer, which is this pointer, being assigned I'm just going to rename this variable to PTR. So otherwise we have. And then I'm assigning then this to null pointer.
Yeah. So basically you're saying your pointer is from one pointer.
I actually put that in
a
small extra challenge to figure out how to do it.
Oh, sorry.
No, it's fine. Somebody wants it was just like if somebody wanted to try it. It wasn't really part of the task, obviously.
Would you like me to do with this? Would you like me to do that?
Actually, before coming, I was experimenting with SDL, something really strange set. Like that, I initially had a set, and then I created a pair of iterator. And then you have the range. You can set the range format and min range. So I set min range, let's say 44, and the next thing in the session is 55. So if you get first and second, you can access the first because it gives you two. You know that. When you, let's say, when you have a for each, right? It's like a streaming job.
Stood for
Yeah,
not range based.
The one that actually allows you to pass in lambdas to like the streaming job. It's called this stem. So when you do that, if it's set, and when you say, okay, my iterator, it's begin and end, and then return begin and end, and pass this lambda expression. So it will just print the content, right? So if you give these two iterators, if you have set, it says 45 and 55 prints it. If you have multi-set, it gives you 44 and 44. I am scratching my head over this. Why? I'll bring the code for you.
Yeah.
I have it on my Mac at home. I'll bring the code for you to have a look at it because it's very straightforward. If you have time, because it just made me scratch my head for a long time. Yes, I did it. I did it in two ways. I either first I created an object with an operator, right? This operator just printed the single cout, right? That was one way. And then there was another way of doing it, which was the lambda that actually started just cout, and then you pass in x into that, and it prints x for you. I did it both ways, and the result was the same one. So multi-set, I had 44 and 44, but normal set I had. And 50. That was great. But I created here. I bring the code for it. It's just made my, what Microsoft compiler, I don't know how GNU compile would do fine. Yeah.
And somewhere
So there's this,
no, the Visual Studio 2015.
15's okay.
Yeah.
Still
Yeah. Okay, that was it. But I'll bring the code snippet for it next time we meet.
Yeah, next week.
Because that was really strange.
only the last few.
That's basically what
So
this
the
is.
early ones we weren't expecting.
Yeah, sort of. Apart from the parameter.
From now on, yes. we
Oh,
will.
those ones.
That's probably why we've only just moved it. That's probably why we appeared in the,
Unless you actually move this thing here, at least if you have this.
Yeah, because
I think so
first
Tom,
thing that gets done is shares the ops. So basically the address that's pick up on one side.
I think he split it.
The first one, so for the first, this first one, we just want to do not point.
And then he goes ahead and deletes the one of the other object.
It's great for us. It's just had we known there were going to be so many
Unless they really screwed up, I don't know about it.
easier to start.
So you get no communication with your when you get.
I believe.
No, you. All we saw was just looked at it today, and suddenly there are 39 people signed up.
Okay.
Usually it's about sort of 10 or 12. So
Is that right so far?
I mean, yeah,
Yeah.
Which we can fix.
it was a bit late in our planning.
There's like operator.
Like I said, all the previous notes were right. This is No,
I don't test for self-move assignments. We don't test.
But no, so now we know. Now we know what we can do is we can go back and cover some of the key points. So the recap we can do, you know, for people who've been coming for a while, they might want to do some revision sessions.
Maybe can you get a different day? I don't want to be about
I didn't require that.
I have to.
and then I assign the new one. In terms of resources, a friend of mine, what is a super good, he has 25 years of C++ experience as an architect. He told me to start with C++, but it's kind of hardcore. I know for everything he gives you like a pretty intense step. He suggests maybe C++ programming or software for very people C++. Do you think that is a good idea? Consider and not completely.
Basically,
Yes. So Tom actually has. So he does a couple of books. So he's got the C++ programming language, which is sort of
easier way is
it's 1,000 pages. and that's
PTR because
very, very
it's
detailed.
already basically the new
Yeah, I don't know if
so you can just
when I started with C++. When I started, I used
you don't want to create a new object,
but you can get one object
Will survive. Well, I hope I do first.
so you
Yes,
need to do this.
but apparently that's very, very good. So I've read online.
And you should probably rename basically your pointer.
One thing we should do actually is put on our website. So you just beginner books. Yeah.
Yeah, I'm stuck with this.
Show me the syntax. No, get rid of the first one.
So, it's not necessary to have compare will know that it's
Yeah, it literally return type is explicit because that is the type.
The one with red.
I honestly don't know. I am a terrible learner on books. I can almost never learn
Or
anything.
at least, where should I start? Sure. 11, where everything like this was introduced.
Yeah, so
I've done it the old style.
yeah. That's actually not as important as you think. So minimum 11. Whether it if it's one that says, oh yeah, it's 14, nice, but it's really not crucial. So once you're comfortable with C++ 11, to the point that you've got all that new syntax, the stuff that's been added in 14 is just going to seem easy because it's a few new features that expect. Like for example, we've got lambdas in 11, right?
Yeah.
So
that I know.
then, yeah. So in 14. all they did was they just made the capture a bit more flexible, so that you can now actually assign values inside the lambda
So
capture.
essentially what was added except lambda was this type of pointer and then
The R value references.
R value references.
Yeah.
Something that's
You said something about G value references.
Oh,
R value and
sure.
G value.
So what they did was they refined
the
the
L
meaning.
value and R value.
Yeah. So in 11 they made it more specific, effectively.
Okay.
So what was considered an R value in pre-11 is now considered a PR value, and they basically expanded the concept. It basically boils down to the fact that you've either got the type, a reference to the type, like you used to have, or this R value reference to the type.
And auto also came.
And then also auto deduction. Yes, that's great.
Okay.
Yeah, and there's some funky rules on that, like auto ref is a deduced type, and that can actually bind to an L value or an R value. So yeah.
It's memory, it's like something else. Okay. And then you like, we want to delete one, we can delete something from the other object. Because we always reassign, because we didn't reset the null pointer at the end pointer. We are resetting the end pointer to an actual object.
So we rely on a lot of feedback.
Yeah. So basically, if you've got a null pointer and something that points to an invalid object, it's the fault of the user. So if it points to an invalid object,
definitely.
And technically, what we need to not happen or not let happen is that we've got a case where we don't reset our pointer. Where, for example, the delete of the destructor can call the pointer, but the pointer has already been deleted elsewhere.
Hey, how are you getting with your unique pointers? Has anybody finished it yet?
We've been nattering about other things.
Yeah, fair enough. Just wondered if anyone's.
If the pointer is gone, then we don't do that.
And you don't need to. We can always call delete on email null pointer. The problem is if the OS reassigns the memory, you can't even check if the address the pointer is pointing to is a null pointer is nothing.
Okay.
So because the OS reassigns it. So if you have
operating system reassign it to another pointer.
So basically, if you delete it once,
yeah,
the OS can then say, oh, this memory can be reused.
Okay, so you're pointing to some dead area which you have no.
And basically, what could happen is that
the
new object gets
fiddle
added
with that and
So in physical terms, the OS might change the memory management unit in the CPU to completely unmap that area of memory.
Another page will be loaded in the page directory and then.
Yeah. So maybe not even that. So when you try to access the address, the CPU just throws an access violation, general protection fault. If it's x86, obviously.
Yeah, of course. Actually, by the way, I'm writing an operating system in C and assembly.
Okay.
I have actually studying the paging of x86 currently. Only the because the segmentation is not very popular anymore.
Yeah.
They just see everything as one segment, each segment, and you have the page right.
Yeah, flat mapping, yeah.
Or
is it because you're trying to exploit Spectre or Meltdown?
No, I'm not that kind of a freak, but but no, I just out of interest started. I'm done with the bootloader. It's very simple. The bootloader is just using if you not with UEFI or
so you're starting out.
It's just the BIOS, right? In the real mode, and then I'm switching to protected mode afterwards, but I have to load the kernel, which is another part. But that's interesting because it's the nitty-gritty stuff.
Yeah,
I like that.
Yeah, massive I've only done it like string out assistant registers.
No, actually, I've got a very good book. The PDF I could email it to.
Oh, yeah, sure.
It's
Is it by Intel?
No, it's by Mindshare.
Okay.
It's an amazing book. It's actually a 32-bit, but the concept is the same.
Yeah.
You have one less level of page directory.
So the idea to release a null pointer.
Yeah, I'll email it to you. If you give me your email,
yeah, we'll give you
that PDF.
Yeah, let me know. I'll give it to you.
Yeah, I've got now.
So
no errors.
We're creating
Congratulations.
So let's see, you know,
But,
pointer,
So
equals
deleting arrays.
R,
So you're assuming that
and
t could be opposite
equals
array time, or
pointer,
is it like what
and
you're
returning
thinking about?
Yeah. So well, my point was more that if it wasn't array
we
type,
prevent firstly that
Terra
then we
would
can
not
do
work properly.
double delete.
So you could.
Yeah, it's, we should,
I don't
we
test
should,
it.
yeah, we should use that delete array.
We'll go ahead and delete in the
operator.
Precisely, yeah.
So it
Yeah,
comes
we'll
with
give you
that.
my email.
And we also calculate your return the original value because we
It's not part of the test.
I'm just gonna send you a test demo, or you can send it.
well, that is just your calculated functions.
yeah.
A new variable,
Implement
something
operator.
Just type in
this pointer.
mind share
So now,
x86
when
as such.
the pointer gets deleted, it won't delete the pointer anymore.
So you've got to filter even the
I get none.
water
Just
which is you can't use it for my price.
That is the operator arrow.
Haven't you done C++?
Yeah, great.
Leave my laptop in care.
Try to
Yeah, you're saying that remove assignments operators, not reset the old operator. So that must be a
Plus or operator plus
and also reset the
I didn't double
also
check.
those
So here's the move.
Return point.
Oh yeah.
also you need to make it constant.
You mean here?
No, it's not a constant point. You can basically yeah. And I believe there's a space between T star and
So-
operator.
T star. This.
Yeah.
I think it will work.
I don't know.
Because from what I remember, the asterisk always can go either
And
this.
I know what
Okay. I'm glad by your experience rather than my inexperience.
you can do what to show.
Turn pointer, so is this.
And it's returning reference to the object of
I
itself.
suppose what we can do is try
For example, if you try to call a function on it, and have you ever seen if you want to call a function on a pointer, so you call something like pointer class, class pointer, something. Then if you want to execute, for example, a function, you do something arrow, the function name. So you want to return.
We just install a toolkit.
It says you want to return a T star.
Yeah, so.
And you want the actual object you're pointing to, not the object you want to point to.
Sub-operator.
Typically, you just want to return a pointer. And then
we currently didn't sound convincing. Yeah.
because then you would
Yeah, I mean, in truth, at this point, it's already set.
as you see, you want to return a T star. What else is a T star in the class?
Pointer.
So I was on, I wish you could go on.
So basically, this does is if you, for example, have store a function class that with functions and everything, you return. I believe it has to be started off. Yeah. I believe it was
Like a value.
you want to dereference it because normally using.
Unless that would be.
Will crash anyway.
And this one's
So basically,
but it's actually expecting it to be the other way around.
so
So yeah, it's supposed to be. So
This is the last one.
sometimes there's a function that's called
oh no, no.
It's actually in some
Let's see,
right in seconds, but you need to know it.
that basically means see in that way I could do the same if I wanted to do
it's not that easy. I mean,
using the dot.
let's
But
give
then
it a
I
go.
have to first dereference it.
Yeah.
I mean,
Yeah, I mean,
it's, in
Yeah,
theory,
success.
it's got to be a solution. It's just, I don't really understand why.
Yeah.
so basically, first dereferencing using the dot. It's the same as using the arrow, because the arrow will give you
Yeah.
back dereference if I'm not too wrong. Since I know it,
Hmm?
how long is the thing booked?
So we have to.
So you'll have to.
So, that's ended up really
Oliver, shouldn't the arrow return you the actual object and not the...
Nope.
No, it's fine. I'm just doing the
Yeah,
bonus
why?
one.
I thought...
It's going to get even harder. This isn't going to work.
For example,
Don't worry about
I
what I'm
thought
doing.
those two were the same. So basically, CL should return the dereference and the arrow should
An
return
operating system. So, I mean, like,
The result I'm calling that function.
that makes more sense.
I mean, that's...
The result of dereferencing is a reference to the arrow operator is not.
yes, they give you. It's a product. They give you a month. They give you a month free.
What happens?
Yeah, they give you a 30-day free trial, and then if you
In this
attend
case,
these things
is this legal?
This one I've just got the one.
It compares, but I was reading this array operator apart from deleting every element
coming to us.
every
don't worry about
every element member of the array. It will then call. It will then call.
Sounds okay, so that's cool.
A function.
No, GCC will do. Most of the examples I do, I try and make sure that they can pass.
Array deallocation is from functions.
It's undefined behaviour. So it probably works because a lot of implementations now can sort of read, you can just put more metadata on the allocation.
Yeah, although this might
Strictly speaking, it's
I understand if
So
in
this case here, how can we actually determine that this pointer points to the array? Maybe there is still some of those.
you shouldn't have too much trouble. A lot of the concepts are the same.
Why it should be runtime functions.
The way you do it is template specialization. So you use template specialization, and obviously it's the whoever's using your class, it's their job to actually say it's going to be like int square brackets, and then it invokes your specialized version that will use the.
Oh, okay, so I should actually create another
You need specialized, yeah. And if you want to do it in the standard way, I think you have to have like an empty you have to declare an empty template.
Yeah,
I've done it before with Windows cursor.
yeah, empty template, and then I would have here T array.
Oh, you can then you can have T array.
It's just I've got
You're taking.
So here,
sorry.
if I'm trying to do the variable,
So it will be if.
the first one is that as
Let's basically have one line.
recursion of
I know, but the thing, the rule,
If you want to do it
it's so like technically. So I know it will be something like
Two things I'll tell you.
something stupid like
Is the
return.
argument in order to perfectly forward it, because the requirement to perfectly forward is
That's it.
Because what it has basically operator board. If you want to do it, then you can actually see what it's
And
the operator is actually now and so basically.
Doesn't like no like seconds.
Thanks.
What does that mean? So what will happen
if you give up the solutions branch.
Similar, but it's a lot easier.
Yeah. But also, I've read the book, Myers and
Well, you don't have much of a background in programming yet? Not really. So you jumped in at the deep end with C++ then? Yeah, why not? Yeah. If you can
Is it
pick good at C++, every other language will seem pretty easy by comparison. What about yourself?
Not gas. I said not gas.
Guess what? Sorry?
Gas. You know, that syntax is the greatest
God.
I've ever seen.
Yeah. Well, I thought theirs is like the
I
8.
don't use gas for when I'm writing my stuff. I use NASM.
So
why is that?
Yeah,
Separately.
because it's a lot.
GNU syntax is just AT&T style.
Yeah, exactly. Well, they try to make it pretty much mixed, like, so you have your destination starting from left,
one thing.
but Intel, Microsoft, or NASM will always
You
work
didn't
like
see in error messages.
and then they have this percentage
Oh yeah.
register. That just makes it so noisy when you look at that. It's one of these, but unfortunately Linux kernel has a lot of gas in it. When you look at the kernel,
But that's a bonus.
gas. They use gas.
You did it.
Yeah, there's a
Whoa.
beta for another group.
With massive. No.
There's some extra ones.
Yeah.
The group has left them.
Really?
I think so.
No, yeah, it's an example.
Yeah.
Can I look up stuff?
Yeah, at least someone.
Make your parameter pack first, that's the start.
Yeah, it's the
This one was me.
You need to make a template constructor.
Fabulous.
Template.
Fabulous.
This one was me.
I haven't done this.
Oh no, that's wrong.
Perfect forward.
Oh, sorry, no, that's not. Actually, no, that's not wrong.
back.
That's a D. I would just to be nice. I would like the term point equals.
I heard about this, but
The arc list?
Yeah. Someone
but
mentioned
the
No, that's literally not
We
what
have
a
that,
parameter
I
pack is.
say for the difference between pushback and en place is perfect forward.
And also, you need to know the
Yeah. I have this is the only thing that I haven't done.
Yeah, so
Everything
So
else
you need one parameter that you can use for the VAs.
These are all content.
but I have to remember this. Back. Yeah, parameter package.
these are not actually const expressions. This is actually
It's just because
You have to finish your presentation.
And my presentation is already done.
I'm gonna present it to them.
He was preparing it like as we speak, and he was like helping me.
That's called multitasking.
It's quite easy.
How many threads are on
You can't text with it as well.
Don't worry. When you get married, the wife proves that you can't multitask.
That's not.
Yeah.
This will be
We can't. We are single task.
But you see, I have an argument some time ago with my wife, and we're talking, and she starts screaming, and you said, like, why are you screaming? I said, yes. Yes, that's the problem. Every time says yes, then they never do.
Yeah. But if you say no, again, it will be
Then you will be in trouble.
If it wasn't. You should use a new, right? So usually, yeah. So it's only going to, that's only going to work.
Perfect I like just the class.
You should probably push it on top of my solution because it's actually better than my solution. So I'll give you that.
I think the CNA thing is probably unnecessary.
It's still it's quite nice.
Well, this is the conundrum.
Because you have no idea what the end is forward.
You know,
yeah, technically yes. We want to construct something with it, so should be compiled.
No, sure. The guys who review who kind of want to. So this is kind of a balancing act.
You mean, are you talking about the bonus and the model?
End up doing half and half. This is something we talked about right at the start.
So what do you need to do? Half-plate,
Right, time to round off. So, sorry, there's not much more left, and then Justin's going to take over and introduce a reasonably basic concept. So, we've got these wonderful. Oh, come on, you can do this. Where's it gone? Hello. No, there's the mouse. Right. So, in summary, as you can see, move semantics are a lovely and very powerful addition to the type category system. As I'm sure those of you who've made a wonderful job of implementing unique pointer have found, the new type system we've got in C++ 11 does give you a lot of power. Obviously, part of that benefit as well is that we can better define our ownership concepts. So obviously, if you think of containers like stood vector, if someone else wants a vector, even legacy code, for example. Say you have an old piece of code that just takes a stood vector and you compiled it under C++ 11, maybe you can't change that function, but if you're not going to want to use your vector ever again, you can stood move your vector to that old function, and as long as it's compiled with the new standard, you've just made a performance saving. And of course it gives us this lovely way of using objects safely, whilst also hopefully and usually being time and memory efficient. So, as I said before, things like stood array, they're not going to give you any saving, but all of those container types like stood vector, stood list, set, unordered set, all that stuff, you're going to benefit from move semantics. So, when you're building your code, the key point I kind of wanted to try and convey to you here was always think about: do I want to copy an object? Do I want to take a reference to a vector? Or do I just want to take that vector because I'm going to mutate it and I do my own thing with it? And then if yes, do I maybe want to move that object and let that person have control of it so that I don't spend loads and loads of memory and CPU time constantly copying objects everywhere? So that's where move semantics is really powerful. Any questions? Going once. Going twice.
Come on, any questions? Okay,
so
questions?
All right, no questions. Good.
That was
so
excellent class. Thank you very much.
All right, well, my pleasure. And now I'm going to hand over to Justin, who's going to cover something completely different.
Yeah.
And even for those of you who, well, you know what, you take over.
Okay.
You say the necessary.
So, what we're going to talk about is, if this works, is basically just bitwise operations and bit fields and some beautiful stuff like that. If I
did you plug it? No, you need to plug in both.
I need to plug in both.
Yeah.
Oh, it takes ages to switch sources.
I have no idea how to do that. Oh, I don't see any screen connected. All I see is screen connected. I would like to connect it to my Mac. Yes. No, just make it.
Monitors have just moved this window to it. So, unfortunately.
This is a wee bit small, is it?
Just present.
Good. We're going to talk about bits and stuff. So, bitwise operations and or how I stopped worrying about memory and learn about bit fields. No worries. We're going to first talk about the general information. What are bitwise operations? What is a bit? How big is the type? Bitwise operations in general overview of them, and then we go more into depth and talk about left shift, right shift, and NOT or XOR instead bit set. which are basically the bitwise operations. The overview. What? Let's talk about bitwise operations. What are they? Bitwise operations are basically operations. For example, a type is a certain amount of memory in your RAM. So you can perform so-called bitwise operations on them. For example, to basically logical, for example, how logical gates do it with values. So why do we want them? Because firstly, they are memory efficient and readable-ish. So when we've got, for example, bit field, we don't have, for example, what I'll cover later, in a character is 1 byte. That means we've got 8 bits, because 1 byte is 8 bit. We can store information for basically 8 different cases, or technically 9. And so we can, instead of having 9 characters, for example, we can have only 1 char in your memory that holds all of these 9 cases. So what is a bit? A bit is either 0 or 1, basically Boolean. 1 byte equals 8 bit. Can somebody tell me maybe what he thinks this will look in hex? If you've done that before?
0.
0. Yes. And this one?
FF.
FF. And how this will be in decimal?
0.
0. And this one?
120.
Some seasoned pros here.
And wasn't it 256?
No.
It's
No, it is 255.
255. Minus 1. But
You're just testing a scientist.
yes.
Yeah.
At the same time, that's also not true, because the lower one can also be minus 128 when using a signed, for example, variable type.
Which kind of signing?
For example, if this would be the unsigned type, for example, if I got an unsigned char.
No, I mean what kind of signed type do you mean? What kind of signing? Two's complement.
Okay. So basically, the highest bit tells whether or not, I don't know if there's implementation, but generally.
Yes, it is. It's two's complement. That's called two's complement. When that highest bit is the thing that says the sign, it's called two's complement. Carry on.
That. So, how big is the type? We covered already char. How big is the char?
4 bytes.
1 byte.
1 byte. How big is the short?
2 bytes.
Still 1 byte.
2 bytes.
2 bytes it is.
2 bytes. How big is an integer minimum?
4.
4.
Technically, it could also be 2.
It depends on
Depends on-
compiler, is it?
Not with we're not there. How big is long?
4.
4. And how big is long?
8.
16.
8. How big is then a float?
4.
4. As int. Same size as int.
That is implementation specific. How big is a double?
Probably same.
Implementation specific. How big is a bool?
1 byte.
1 bit.
1
1
bit,
bit.
technically, but if you only got 1 bit in your 1 bool in your whole program, so basically your program consists only of 1 bool. This bool will be 1 byte, because every bool gets stored in an underscore bool, if I'm not too wrong. So basically you've got a byte type where the compiler stuffs all the booleans in for.
What if I have 1,000 bools?
Then you basically get the nearest amount of the 1,000. For example, if you got underscore byte should be 1, underscore bool should be 1 byte. And so, for example, you can store 4 bools in this byte. If you got 3, 8, yes.
Is this small size optimization basically?
Yes. So basically, these are the values. An integer should be 2.
Sorry, just a question.
Yes.
I thought the size of int was dependent on the machine type.
Yes,
Um,
which is a word based on the word.
And long in Linux, 64-bit is 8 bytes as well.
Yes.
On Windows it's 4.
I'm talking about minimum values, basically. If that went wrong.
Minimum size.
Minimum size. And so technically, if you use, for example, cstd_int, we've got great types, for example, like un32t. That basically tells you this is an unsigned integer of the size of 32-bit, meaning 4 byte. Yeah. Or un64t and those beautiful types. So, we've got a general overview of the operations that you can perform on any memory space, technically. You've got and, or, XOR, not, and left and right shift. Yes, Oliver?
What's the difference between and?
And is basically just saying, if you've got, for example, in a if statement, two statements, it compares two bools, basically.
It's a logical operator.
A logical operator, not a bitwise operator.
Yeah.
Triple?
Well, if you have
Shouldn't you
one and the single and both sides of the operator gets evaluated no matter what. But if you have two ands, if the first one gets false, the other one doesn't evaluate.
For example, got operator and you will override, for example, that bitwise operation.
Just in a setting interview, in an interview setting, on a way to be precise, shouldn't you call it bitwise and bitwise or and so on? Not to be ambiguous, usually.
Yeah, technically you can. That bitwise. Well,
bitwise versus logical, yes. Correct.
Yeah.
So let's
I think usually when you say and or, you assume the bool.
Yeah.
Okay.
Shifts. Basically, what a left shift, for example, or a shift generally does is shifts bytes around. So left shift, for example, this one will take the first byte. This is the given one. We've got basically the last bit set, and we shifted by 5. That means that this value gets shifted 5 times to the left, and will end up here. And basically, this will be the same as this instruction if you would write this in code, technically. Right shift.
Question: if I give a value which is bigger than the size of in bytes of it, do I get an error? Like if I do
I will come to that in the right shift. The right shift is technically the same, but to the right. But in this, for example, we've got value that has bytes at this side end, but we shifted 4 to the right. So what will happen, for example, to these 3 bits? They just fall over. And this will basically just create it with basically this will all be 0 and set to 0.
What happens when you, let's say, overflow? I understand that you just lose this part, but do you get an error if you put a number which is too big?
No,
or
they just
not?
fall.
They just fall over.
It's fine, okay, cool.
Yeah, so basically these fall over this side and nothing gets, they don't wrap around. And also for completeness sake, I've written the one of the Intel instructions for X.
Yeah. One thing to mention as well is that on Intel you have these shift instructions. My memory of the x86 instruction set is rusty-ish, but I can tell you that on ARM, so what powers your mobile phone, they actually have a rotate instruction, and then the bits don't fall off, so it will literally loop around. You can rotate
yes,
that.
they do have it in x86 too.
It does.
Shift
yeah.
R.
It's CISC, so you think it does.
Yeah.
So, bitwise AND. Basically, AND compares the bits of a byte and only sets those where both are set. So when we compare this, these two ones are set, therefore the result will set this bit. So this bit and this bit is set, will result in a 1. Whilst, for example, in this case, there's a 0 and 1. This cannot be 0 and 1 is not possible. Therefore, it will set the 0. And this for the whole thing will result in this. And technically, now we come to actual bit fields. What is a bit field? I've written too much to this. Well, a bit field is basically an amount of memory that you can assign instead of more information to than it actually is. For example, in a single character, you can put 9 states technically. So, for example, we've got, I've made C-like example because it's quite easy. We've got an enum of entity flags, and basically we have for no flags the no bit set, and for the invincible flag, for example, we have the first bit set, and for fly we've got the second bit set. This basically means we've got the first bit set, but then shifted one to the left means the second bit. Now if we have, for example, character flags, if we want to check the character flags, for example, we can just, if the character flags and the entity flags fly, we do fly. Because if, for example, this character, if we would check that this one would fly, we would check if the result, for example, 0, 0, 0, 0, 0, 0, 1, 0, those two and each other will result in null, because these two then, I didn't put my image up, then those two bits aren't equal. Therefore, it will result in a null, and therefore result in false, basically.
Question, can
Yes.
you use the bitwise AND with a variable of different type? Say, for example, I don't know, one short and one char. Does it work?
I believe you need casting for that.
No, you don't.
You don't?
Short and char will just work.
Short and char?
Short and short.
Yeah.
Okay.
You can't. If it was like a class or something, it'd fail horribly, of course, unless it had a conversion operator.
Okay.
Yeah, you can bitwise and type. Now,
Even
where
if they're
it
different
get-
size.
Where it get, so if you're just using them for a conditional, you can do it. If you're going to store the value, then it's going to be type promotion. So if you have say a short and char, and you bitwise and them, you can guarantee that the upper 4 bits of your short are gone, because the char's obviously going to promote to those top 4 bits 0.
So say, for example, I wanted to encrypt with an XOR and a given number of characters, that would work.
Yeah, it'll just it'll extend the small value to the size of the larger value.
Okay.
But there wouldn't be 0, obviously.
Not as basically. Sorry. Yeah.
Sorry, the last slide you had fly, one left shift, one.
That
is that just convention, or can you just?
That is left shift. If you see here, this basically is 1. Like this is number 1, and if you shift the number 1 by 5 to the left, we will get this result.
Yeah.
So basically, we would compare a result where only this bit would be set to the.
I think what he means is that, like, imagine you're going to stick 20 values in an enum like that.
Yes.
How would you visually choose to represent them? Like, would you just use 1 shift 1, then 1 shift 2, 1 shift 3?
Technically, I would use 1 shift 1 and then 1 shift 2, 1 left shift 3, 1 left shift.
Okay. So that's convention, isn't it?
I'm not too sure about convention. I'm just seeing people using it.
Yeah.
Like
I would agree. I would do it.
You could equally write 2 and 2 to get.
technically, you can also.
It's less idiomatic. And also this way you can see what error.
Also, there's a reason why I write C-like check and not C++-like check. Basically, not is inverting. Just we don't need 2 types because this will just get flipped over, basically. So the if you not this will result in each byte will get basically set to the opposing one. Yes.
What does r/MA163264 mean?
Not
Sorry, I'm just making him do this.
R is basically a register or memory, so we can reference the initial in x86, x64. We can reference an 8-bit register or memory address, and 16-bit or 32-bit or 64-bit, and basically flip the bytes of those.
So it can be any combination of these.
Yes. Yes. So, let's see that example for this. If you want to flip, for example, those flags, this flag, we just assign it to the flipped version of this. So basically the AND C will flip all those bytes, which will result in 0, 1, 0, 1, 0, 1, 0, 1. That's 8. Coming to OR. The OR, like we've seen before, is this little bitwise and bitwise OR is this little operator. So if either one of those is set, comparing two values, it will set the result to that. Yes.
I think the second number is a 9 bits. Is an error or I'm missing something?
Second number? I have
But yeah.
1 0 too much. Yes.
Ah, okay.
It's
Okay.
So basically that would result this. See like example. If you want to, for example, compare multiple flags. So I've got an entity flags here, can fly, can meow, can bark, and has 7 lives. Like there you can see how I would personally do it. And then we've got a sharp presumed cat, and we can AND this by the basically flags. So if the presumed cat has the bit can meow and has 7 lives set. I should have made this more visual. Oh. So basically, yeah. XOR, exclusive OR. This is basically like OR, but the thing is that only bits are set which are basically, if both of them have 0, that will not be set. If both of them have 1, it will not be set. Because, for example here, both of them are 1, that is basically exclusiveness of this, thing, it will not set the bit. But if only one of those is set, then it will set the byte. And where is this useful? For example, in XOR encryption. This basically means that we've got the type, for example, in like choosing A as an example. This is a ASCII. And if we XOR this by this random value, we get back, for example, this number, because yeah, we XOR. And if we have XOR this basically encrypted number by the same key again, we will get back the same result. If that's understandable.
Well, the way I put it is that, so basically what we're saying there is, you imagine, oh, I don't want to do this really, but right, you should use the laser. There's actually a laser. Anyway, imagine that's your plain text, and then that's your encryption key. That's your ciphertext, your encrypted text. So if you take the encrypted text and then XOR it again with your secret key that you know, you get the message back out. That's it. Also, it's actually the most secure form of encryption you can do, providing that your key is in equal length to your message. And obviously nobody finds out your key.
So bitset. Bitset is basically bit kills gone easy. This is implemented in C++, I believe 11? Not too sure.
I think it was 11.
It was implemented in C++ 89, 98, and just some of them are 11. Anyway, it's basically easy, it's the C++ standard, and also more idiot-proof, meaning that you can't mess some things up. So basically, if I this would click, basically now we've gotten entity flags again, and we can just have a bit sets of the size 4 with this basically bits that we constructed with. Then we can first, for example, check if all of them are set. For example, if it's invincible, can fly, can create. And technically also none, because that's 1, 2, 3, 4. All of them.
This is actually a real question.
Yes.
You can actually pass it a string.
I can pass it a string, yes.
Didn't know that.
So basically say if all flags, all bits of this is set, it should do God. And and else if just the can fly bit is set, it's basically test whether or not the can fly bit is set. This will be the second bit. Should be. So basically test this bit, not too long. Then should fly. Yes.
Enum class is automatically convertible to bit sets? Is that direct conversion?
You technically need to set a cast to an integer.
Okay.
If I would have removed the class there, it would work because they get then used as the type of things.
Use your imagination.
Yeah. So, quiz time. What I want from you is basically read the implementation of bitwise, not implementation, read the documentation of bitset and recreate it in my, basically not framework, in my harness that I've made for the bitset on GitHub, which should be.
Justin, your GitHub username is too difficult to type.
I can post it on Slack.
No, it's
clone it to the CPP London.
Sorry, can you just go to the previous slide? Just.
Yes.
Okay. No, I was just wondering because you. I was looking the name of the enum class and the name of the variable. For some reason, I thought they were just the same, but they're actually there is a difference.
Yeah, it's more
in the capitalization. Yeah.
I'm doing this programming for 3 years. I'm not the best in all of the standards.
You're fine for that.
So yeah.
Okay.
Anyone needs help? Anyone needs?
Sorry, I've got one question on the previous slide. So, reading from left to right, 1 0 1 0. That first one on the left is the same as the num, is it? Corresponds to num.
Basically, if no bits are set, that means technically.
Okay.
If I test 0, it should be. I think it should be right. It should be wrong there anyway. And it should test this bit.
Okay.
So basically, then invincible would be this bit.
Okay.
Can fly would be this bit, and can create would be this bit.
Right. Okay.
So basically, as in an enum, normally if you don't specify a difference, it will start with 0, 1, 2, 3, and so on. So basically, we've got non-invincible, can fly, can create.
Can I ask you, I was reading a reference, but it doesn't tell me too much. In terms of memory management,
yes.
For example, a bit set of 4 takes 1 byte, just for byte, is like the boolean which gets managed smartly, or how does it work?
Sorry?
Assume you now create a bit set of 4 bits.
Yeah.
Okay. This in my memory will take 1 byte, or we get put together like the boolean. How does it work?
I am not too sure that's properly
It's implementation defined. So the standard says that bit set must do this. How it physically achieves it is implementation defined. It's going to depend on what platform it's actually running on. So you can probably bet that if you implement this on a 64-bit machine, then the minimum size of instruction it's going to emit is something that operates on like AL or AH.
Okay, so they cannot, for example, if you created 2, they don't get merged in 1 byte like the booleans.
It may do, it's possible.
It might.
If someone has written a really clever standard library implementation, like maybe libc++ or libc++, they may have done that, but you have to look to know.
Okay, thank you.
Some tests and also functions.
No, where is this?
Oh, sorry, that's in there.
Oh.
Will these links be accessible from a website or something?
Will what be accessible?
These links.
Oh, the slides?
Yeah,
we always
slides.
upload the slides.
The link.
Yeah,
It's set as just one byte.
I mean, after the class is finished, yes. I mean, not the same day, but I try usually the following day,
create like a summary of what was happening and so on. And I try to, as soon as I get the links to the slides, to put them there. So if you have any questions, go to our website, go to blog, and then you see the details about, you know, the class.
This is also the homemade bit sets now on the CPP London Uni. Forked just like that. So the CPP London Uni.
Oh no, that's the index, sorry.
Just a question.
Yes.
The test method takes int instead of char. Is that the way it's supposed to be?
Yeah.
Because the bit field is actually char.
Yeah, the bit field
No, that's
basically just
fine.
says
So we're doing the test.
What
1
else?
byte.
Okay, right. But the test takes bigger than that. Does that matter?
That is technically done, yes. Could be optimized, but
So it should be char. Or
could
does
be
it-
sure,
doesn't
doesn't
matter.
really matter. Well, if you specify anything over end, you can potentially go to get other parts of it.
Okay, all right. Thanks, man.
No, we're trying to recreate it. So what we need to do is
we
like
will
this
not be
example
creating
of,
a template.
where he had those.
We will be just
you
using
needed to do.
Just do what, just if you look at the bits
okay.
of the CPP, basically just fill in these functions and make the test pass. That's
okay.
what
So
I intended to do.
Oh, okay. So okay.
Because technically the
I could see that it uses that non-typed template argument.
yes.
That
Yes,
STL.
that's what I didn't want
Oh,
to
make it
conflict
yeah,
with
yeah,
people.
yeah. Okay.
So I've just made it basically, if you scroll down to the
yeah,
bottom, you can see that I'm just using 1 byte.
Oh, yeah.
So hopefully I'll make the test script.
Yeah, this is
Does it mean that we can have only 8? Does it mean that we can have only 8?
so if he says it field 0, that's the one. If it says if index
Bit set, we can set the size of it.
So the ending
But
is about
in this implementation, basically, you just have 8 bits.
Bits is the size of the.
Yeah.
So index one
Oh,
is
okay, that's so
1
it's
byte,
a some.
8 bits.
Yeah, yeah. Oh, okay.
I think so.
that's one.
Oh, we're only got 1 byte, so ending this.
Thanks.
That's not entirely true. There are architectures where it still matters. There are some architectures that actually have endiness on the middle, on the core. But yeah,
Oh, I see.
generally speaking, no, it's right.
What
Okay, so we start indexing.
What architecture? ARM?
No, not ARM. It's not. No, not ARM. It's
Mix?
not like crazy.
ARM?
No, it's something very old. Something very old now. Like we're talking like some old. It might be some old Motorola, like not
Okay.
MOS, but can't think of it now. But there is one.
Oh, they have, they could actually address nibbles.
Yeah. Actually, I'm not sure if it could even address nibbles. I think it might have been the case that it had like 4-bit memory, and that was what affected it. It was something like that.
If you're going to put it on the stack, you at least should have 1 byte allocated.
Yeah, exactly. You'd think.
Yes. We're going to have I'm just looking for the top constants first. Can check if all bits are set. That's the all. So it looks like we passed the test for the first one.
So using what would be these other languages.
Pass this small, we've got a small program. Pass the test for test, absolutely, yeah. So
Do you want to execute the code or just see what
No,
it says?
execute the code better get. How do I assess the content of a class? Using what in JavaScript would be this or a self in other
Same
What's
thing.
this?
Bit
Yeah.
field
It's this. So you don't have to though. So if you have a field or a member function, you
Well,
could
one
just
way we could do it is just.
if you're inside of if you're in the scope of a member function, you don't have to use this.
That wouldn't be
But
very.
if you want to, you can. You do this and an arrow, and you can access its fields and everything. But the compiler is smart enough in the C++ standard. It says, well, actually you can just call the member function or access the member field and the compiler figures it out. That it's, oh, this is zero. But if you want to be explicit, use this.
Okay. Use that best practice or?
Yeah, so you can write.
It's a matter of taste. There's not really any agreement on it. I personally at work don't. I rarely use this.
The arrow is lim arrow or the cut arrow?
Dash and then great.
Yeah, it's 2,700,000.
Yeah.
Ah, as opposed to comments, okay.
Yeah. So Java, I think you use underscores. It's the only thing
The reason it's narrow is because this is a pointer.
So it
makes sense. So is it?
it's what if you wanted the string to
Oh, that's
still the old way.
That's well, you the string.
No, yeah, I see that.
But you can only put one thing into it. So that this is just a digit. So that's, if I took that out, it makes sense. And this is a binary literal, so this is another new thing in C++ 11. This is you don't have to deal with text nesting, which is good because just write out to return the bit field and so all of them are set. See whether that one comes. Can check the ball that's a fake.
Nice to meet you. See you.
You get it right?
Yes.
It's solved. Okay. Or solvering. Okay.
That's interesting.
It's my bag, right? That was.
This is the same work?
Yes, I believe so.
Okay.
What's wrong with this test?
I'm not saying that it should have happened, but that's fine. Yeah. Yeah, that's it.
So basically, when you do not return,
Yes, we can as well.
Do you think this is correct?
No.
No? You don't think that's
Let's say the bit field was 1, and you and it with that A, then you're going to get 1. If bit field is 10, it's still going to be more than 0. So the ball is going to convert from anything that's non-zero. So anding it, if you and it, it doesn't. That's any. That's not it. Just to be clear, all means that every single bit.
I didn't try that yet.
And and is not correct.
Giving me CMaker maximum, CMaker minimum required.
just need to exchange what
Every bit set, what's the value going to be?
So I have 254.
If you know the width, if you know the size
or
of
we
your
can
bit,
just export it and see that it doesn't return that return 0 and then negate that. If you want to do a couple of export, maybe the next one you use can try and
I still remember what this is now.
Yeah.
Oh, I see. Oh, yeah. So why is there? Oh, okay, yeah, okay, yeah. All right.
No, actually, please, you've got Tris.
Oh, I always have to think really hard whenever I do this bit shifting stuff.
Yeah.
Comparison constant all the time, char is always false.
actually will answer for all this.
So you want to return?
No, it's 100%.
Yeah, it's basically what we had before.
And
We're getting confused by looking at the final value versus the individual bits.
so you want to say that?
None is the same as all.
So I think
You can say not.
equals to 0. So let's go to the test. Check b1.all. It still doesn't like this. This is probably the compiler one we want to get to.
Using an class, your lecture that you supposed to present to attend, and then classes. We're using it very often. Cool. And it works. And now I never use now N. I just always now just type N class and that's it.
Right. So this is one of the horrible things about C++ is that it will convert your types from drop down. So what we're having to do is, for the field is of type char, we have to make sure that the thing we're comparing it to is of the same type. Otherwise we get all the other way. Just make sure that we're comparing two things at the same time. Yeah, because it would have seen this binary constant as an int, which promotes the field.
Does that mean that's the same thing?
This one should be okay, I think.
Because 0 is a valid charge.
This one I think. Okay, so we've got as far as counting the tests. So it likes all of these tests.
Using bitfield instead of this. Use the same.
This is not bitfield. This is basically just one class that you can perform functions on.
So we've got count.
Actual bitfield bits and then
How many bits are set?
if you look in the header.
Does it have to be full? No, okay. Just use the use the test with the folder.
Yeah, this is not. This is a one to class of bitset. So basically, if you call
Sure, size.
this
Interesting Android sticker.
Yeah, I've got it.
Now green flag.
Yeah, they just make you can make custom ones, and I saw that.
That's cool, yeah.
Yeah, that looked cool. Gave it a go. Sorry for my noisy 15-year-old laptop.
15 years, really?
Not 15 years, that's an exaggeration, but oh my god, it's fans that will go in.
What version of Windows does it come with?
We're going to test each week individually.
Yeah.
I've got one.
More efficient ways of doing that.
Oh wow.
Yeah. That's a real piece of work. That's a real piece of work.
Sorry guys, 5 minutes ago.
Not even a question.
Yes, one second.
Sorry, the size of return is 1, doesn't it? Returns the size of bytes, doesn't it? My mistake.
Times. Actually, strictly accurate.
I think
So, okay, so the way
the stop on.
we could have done
the
this.
kettle from running away.
Barbed wire.
Barbed wire. It's like you know, it's climbing on the barbed wire.
Yield and on
Or sliding on it.
index like that.
That sounds even worse for sure.
What's the source of it?
But if they want to assess specifically that bit,
Then should technically, if you want to
Size of the
anyway, is
because it was more efficient because I don't do a shift, so just compare that bit.
Hi everybody, we will have to be finishing now within next 2-3 minutes. So just to recall, after the meeting, you're very welcome to join us. We're going to the very nice pub called Beer Schanke. It's like a tradition. It's a nice beer, something to eat if somebody is hungry. And we'll be chatting about other stuff as well to know each other. I'm so glad we've seen so many new faces. We hope you all come back. We need your feedback. We very much so need your feedback. We need to know what you want to learn. Without you, as I said, it's me screaming against these guys. And if I don't know what you want, I cannot represent you. I'm just giving feedback, sorry, the voice back to Justin so he can finish off. And I hope to see you next week. So send me the feedback.
Yep. Any questions? Rose up, or yeah. If you've got any questions now, technically because of the shortage of time, not really. But if you want to ask something, feel free to add me on Slack, in CPP London, or PM me, or I'll try to answer as best I can.
Do you have a solution bench for your exercise?
The solution is it's a branch in Git.
Okay, I just close this.
All right. And thanks to Justin.
Thank you, Justin. I definitely should learn from you the tricks about making such nice presentations. My presentation usually sucks.
I like the font. The font was very
The trick is, just using the font, you pick different themes.
But have you seen Phil Nash presentation?
Yeah, he goes all out.
I mean, he's doing amazing presentations.
A little bit more time, was it done in national PowerPoint, a bit more like efficiency stuff?
Yeah.
Absolutely required. We use CMake for this routine, so CMake is a core system. Most IDEs will support it. If you want to download CLime and it can kind of help with